Okay, here we go with homework 4-5. You're computing probability involving the addition rule using two-way frequency tables. So here's data for the particular day a restaurant is open for lunch, has 124 customers, and you can see for lunch which ones got dessert and which ones didn't, and same thing for dinner. So the question down here, what is the probability that a customer ordered dessert? Okay, so if we're looking at that, you have 124 customers that day. Tell you that up here. You can also get that from adding all these numbers here together. So you have all those customers, and you're asking yourself, well, how many of them ordered dessert? So if I look under my dessert column for lunch and dinner, I had a total of 63 people out of that 124 ordered dessert. Okay, so probability 63 out of 124. And let's see, what did they say round this to? Say round it to the nearest hundredth. So I typed that in my calculator, get a couple of decimal places. I'm going to say about a 51% chance that's going to happen. All right, next question. What's the probability that the customer came for lunch, that a customer that came for lunch ordered dessert? Okay, so I'm only looking now at my lunch, folks. Okay, so I'm just going to look here. These 77 people that came for lunch, how many of them ordered dessert? Well, it looks like 23 out of that 77. So 23 divided by 77, round it to a couple of decimal places. You got about a 30% chance that somebody coming in for lunch ordered dessert. All right, that's how you're going to tackle that problem. Let's go to the next one. Okay, probability of the union and intersection of independent events. Okay, and again, this help. I use Venn diagrams to help me with this. But here's the thing you need to understand: when you see independent events, you're going to have a situation like here's event A, and here's event B. And if these events are independent, this area, this intersection right here, is going to equal the probability of A times the probability of B. That happens when you hear independent. You got to know that that intersection right there is equal to the probability of A times the probability of B. Okay? So let's tackle this problem here. It says, suppose that A and B are independent, so we know that this intersection is going to equal the probability of A, which we know is 0.5, and the probability of B. Now, what they give us here is probability of the complement of B. So that means the probability of B is 0.7, because these two things right here, that's the complement, the probability of an event and its complement have to equal 1. And so if that one's 0.30, this one's got to be 0.70. Okay, so I'm back to probability of A is 0.5, probability of B is 0.70. If I multiply those together, I get 0.35. So this area in the middle here is 0.35. Okay, 0.35 is the area in the middle. So now we can start answering these questions. It says find the intersection of probability of A and B. So the probability of A intersect B is 0.35. All right. The probability of A union with B is going to be all of A, which is 0.5, right? So I'm going to say 0.5 plus all of B, which is all of this right here, and that's 0.7. However, we counted this area twice. It got counted both times. So I got to subtract that out one time because I don't want to count it twice. I did, so I'm going to subtract it out one time. So I'm going to do 0.5 plus 0.7 minus that intersection since I counted it twice. And that answer is going to be 0.85. So the probability of A union B is 0.85. The probability of A intersect B is 0.35. All right, these problems you're going to see a bunch of, so make sure you have a good understanding. If you need more help, reach out to me and I'll help you. All right, last one. Probability of the union of mutually exclusive and independent events, okay? All right, so we just talked about what independent events look like, okay? And that, but now mutually exclusive events are going to look like this. If this is event A and this is event B, these events are mutually exclusive because they have no overlap whatsoever, okay? Independent events are going to look something like this. There's going to be some overlap, and we know how to find this intersection. It's the probability of A times B. So let's see what these questions ask us. Let M and N, well, let me get the right letters up here then, I guess. It says let M and M, probability of M, N, probability of M is 0.28, and the probability of N is 0.19. Determine the intersection given that M and N are mutually exclusive. Well, here we go. If they're mutually exclusive, there is no intersection. Oh, sorry, this is not asking for intersection. This is asking for union, okay? So I just got to add these together to get the union. So I'm adding 0.28 and 0.19, and I'm getting 0.47. That would be the union of M and N if they're mutually exclusive. Now, what if they're independent? How do we find the union? Well, we add them together. This is 0.28. This is 0.19. But remember, this little area here is getting added twice, so we're going to end up subtracting that out one time. The way we find that area is we multiply 0.28 times 0.19, and we come up with 0.0532. That's that area right here. So I'm going to say 0.28 plus 0.19, subtract out this area that got counted twice. I counted it when I did my 0.28, and I counted it when I did my 0.19. So subtract it out one time, and type that in my calculator. 0.47 minus 0.0532, and I get 0.4168. That would be my my answer for that one. All right, let me know if I can help you. Good luck.